reactions of diazonium salt. So there are 7 reactions. I have shown here the number that indicates something, that you can prepare 7 different substituted benzene with the help of this diazonium salt. Okay, which are those reactions? That is nothing but the Sandmeyer reaction. We will see these reactions one by one. Okay, so the second one, that is Gattermann reaction, then reaction with potassium iodide, then Waals-Schiemann reaction, that we will see what is this reaction. That the reaction is used to form the fluorine substituted fluorobenzene. Okay, then with dilute H2SO4 with fluoroboric acid, and at the last we'll see the reaction with hypophosphorus acid. So these reactions we are going to see. So one by one we will see the reactions. And okay, so Sandmeyer's reaction. So Sandmeyer's reaction, before that just we'll recap for the formation of benzene diazonium chloride. Okay, so this is benzene diazonium chloride that we are going to form with this aniline. So this is aniline on reaction with nitrous acid. In previous lecture we have already seen this reaction, means NaNO2 HCl. Okay, NaNO2 HCl at cold condition gives benzene diazonium chloride. So this is N2 plus Cl minus. This is benzene diazonium chloride. Okay, in this reaction we will get the byproduct, that is HCl. So with the reaction with this aniline, means from aniline you can prepare different types of functional groups. Okay, so this nitrous acid on reaction with this aniline, that is nitrous acid is prepared from this sodium nitrite, and HCl gives you benzene diazonium chloride, and this NaCl is a byproduct. Okay, sodium chloride. Now we'll see one by one the reaction. That is, first reaction is nothing but the Sandmeyer reaction. What is this Sandmeyer reaction? So directly we are considering the benzene diazonium chloride. Okay, Sandmeyer reaction. So Sandmeyer reaction is nothing but the when benzene diazonium chloride is reacted with, so this N2Cl, N2 plus Cl minus, when this benzene diazonium chloride reacted with copper halide in presence of HX, it produces halobenzene. So what is the drawback of this reaction? That this only produces for this reaction can be explained only for chlorobenzene and bromobenzene. Okay, you can additionally prepare cyanobenzene from this reaction. That reaction is called as Sandmeyer reaction. So you can write both these products which are shown over here, that this N2Cl, N2 plus Cl minus which one reaction first with copper. Suppose here this chlorine we are preparing, that's why it is copper chloride in presence of HCl gives chlorobenzene. Chlorobenzene plus En2. Same compound which when reacted with copper bromide CuBr in presence of HBr gives bromobenzene and En2. Same compound when reacted with copper cyanide CuCN in presence of hydrogen cyanide, again you will get this cyanobenzene. Plus N2. This is nothing but the Sandmeyer's reaction. Got it? Preparation of chlorobenzene, bromobenzene and cyanobenzene. So this reaction is again takes place with the freshly prepared, you can say the benzene diazonium chloride salt, okay, which when reacted with cuprous chloride or cuprous bromide, that produces the particular chlorobenzene or bromobenzene. Similarly for the cyanobenzene. Okay, we'll see the next reaction. The second reaction is nothing but the Gattermann reaction. Okay, let us see what is this Gattermann reaction. Gattermann reaction. So in this Gattermann reaction, you can say that the reaction is only with the chloro or bromo compounds. Okay, now see here, when this En2 plus Cl minus. Okay, this is your starting compound, which when reacted with first copper in presence of HCl gives chlorobenzene and plus En2 as a byproduct. Similarly, in presence of copper and HBr, it produces bromobenzene and nitrogen as a byproduct. What is the difference in that Sandmeyer reaction and Gattermann reaction? In Sandmeyer reaction, we had used cuprous chloride or cuprous bromide, but here we are only using this copper powder. Okay, so this copper in the form of powder and in presence of HBr suppose or HCl, we are using this reaction. So this is only the difference. And if you compare the Sandmeyer reaction and Gattermann reaction, This Sandmeyer reaction is having better yield as compared to this Gattermann reaction. Understand? So this is the difference. In Sandmeyer reaction, we had used this cuprous chloride or cuprous bromide, but here just we are using this copper powder in presence of HCl. Same reactants and same product are going to form, but the condition reagents that are different. Now we'll see the next reaction if this is done with potassium iodide. Okay, the reaction with potassium iodide with Ki. So this reaction is nothing but the, if you try to perform this reaction as a Sandmeyer reaction or as a Gattermann reaction, the reactivity of this iodine is not as much that bromine or chlorine. That's why the cuprous iodized, suppose you are using for preparation of iodobenzene, does not give you the iodobenzene. Okay, so that's why this iodobenzene, whichever we are preparing, is just preparing with the help of this potassium iodide and on heating. Okay, it gives you iodobenzene. Therefore, when the solution of diazonium salt is heated with potassium iodide, then iodobenzene is obtained. So this is iodobenzene. For this reaction, this cuprous iodide, okay, it does not used. We are using potassium iodide. Okay, done with this reaction. I think this is a simple one-line reaction. Benzene diazonium chloride on reaction with potassium iodide or on heating with potassium iodide gives iodobenzene. And here the byproducts are the potassium iodide, or your this chlorine is attached here, and plus nitrogen. They are the byproducts. We'll see the next reaction. Balz-Schiemann reaction. Balz-Schiemann reaction. This reaction can also be known as the reaction with fluoroboric acid. Okay, or you can say that the reaction with the which prepare the for preparing fluorobenzene. Okay, for preparation of fluorobenzene from benzene diazonium chloride, we are using this reaction. So this is benzene diazonium chloride, which on reaction with HbF4, this is also called as fluoroboric acid, okay, produces this salt, that the salt is nothing but this benzene, okay. Then here this N2, N2 is again plus, just this hydrogen is chlorine is replaced by this BF4. This is fluoroborate now, okay, which on further heating, on rearrangement, produces this fluorobenzene plus HBF4, okay, plus BF3 and nitrogen. This reaction is also called as Balz-Schiemann reaction for preparation of fluorobenzene. Now, we'll see the next reaction. The reaction with dilute H2SO4. So, what is the reaction with dilute H2SO4, that we will see. With dilute H2SO4. So, this benzene diazonium chloride on reaction with benzene dilute H2SO4 N2 plus Cl minus, reaction with dilute H2SO4 gives phenol. Gives phenol. Okay, and the byproducts are nothing but the, here this HCl plus N2. These are the byproducts. Okay, ultimately if you see this reaction, this NH2 group is converted to, ultimately what is, how this benzene diazonium chloride is formed, with the help of this aniline. So aniline to phenol you are preparing, okay. So the conversion of aniline to phenol, okay. So this is the ultimate reaction, understand. So this is negatively charged or electron donating group is there, this is also electron donating group. So this is quite like a nucleophilic substitution, but these aromatic compounds does not show nucleophilic substitution. Okay, so we'll see the next reaction, that reaction with again fluoroboric acid, which will be forming the nitro compounds, okay, nitro compounds. This reaction is also with fluoroboric acid, but this reaction is going to form the nitro compounds. How? The second step is different with fluoroboric acid. With fluoroboric acid. So sodium nitrite we are using here. So what is the reaction? This benzene diazonium chloride N2Cl minus and this plus, which on reaction with HBF4, that is this fluoroboric acid, gives you the intermediate. This is the intermediate, that this N2 plus and HCl is a byproduct, that's why it is BF4 fluoroborate. This gives, in presence of sodium nitrite and copper, on heating, this nitrobenzene NO2 group. Okay, plus the compounds, that is nitro group, HBF, NaBF4. If you only hit this particular content, we have seen in the last for preparation of fluorobenzene, only we have heated. Okay, just heated this intermediate and we'll get the fluorobenzene. Okay, so the reaction is, the step, second step is different. So this is the reaction with fluoroboric acid followed by sodium nitrite. Followed by sodium nitrite. Okay. Okay, we'll see the next and the last reaction of this lecture. That is the reaction with hypophosphorus acid. What is this hypophosphorus acid? So the reaction with hypophosphorus acid. Hypophosphorus acid, it is also called as phosphenic acid. Okay. It is also called as phosphenic acid and the formula is H3PO2. This is the formula, H3PO2. So there are more number of hydrogen atoms, means it is an acid. Okay. So just the salt is going to protonate. Which salt? That this benzene diazonium chloride salt is going to protonate this N2 plus Cl minus. It is going to protonate in presence of this H3PO2. Can you guess the product? It is nothing but the protonation, just the protonation. That's why it is hydrogen. This is nothing but the benzene. So we can prepare benzene also with the help of this hypophosphorus acid, or you can say this benzene diazonium chloride salt. Okay, ultimately what is the reaction? We have removed, ultimately we have removed this NH2 group, okay, from the benzene ring, and we'll only prepare this benzene with the help of this diazonium salt. So these are the different reactions which can be shown by this benzene diazonium chloride. Okay, so almost we have seen the 7 different reactions by using this benzene diazonium chloride. Understand all of you? Or the different reaction, there is another reaction for this. You can use different reagent also for this. So this is the benzene diazonium chloride, N2Cl, N2 minus Cl plus. This benzene diazonium chloride on reaction with ethanol, C2H5OH, that also produces this benzene. Okay. Just the proton donor is required. That's why this is the benzene. Okay, and the byproducts of these reactions are nothing but the N2 plus CH3CHO. Oxidation of this ethanol takes place, and HCl. Do you understand this? Also, if you try to write down the byproducts, I think I have not given here this. Byproducts are the nitrogen. Okay, then here it is H3PO3. This is it, hypophosphoric acid. Okay, and then here it is HCl. So we conclude here. For such important and informative videos, please subscribe to my channel Chemistry Learners and don't forget to press bell icon button. Thank you.